Good morning, dear students. Today I am up with an interesting topic of disk scheduling and management of your module 6. So let's quick start with this disk scheduling and management topic. Let's see what is there and what are the topics that's coming and inside that. So like CPU scheduling, we have disk scheduling. Now what is a disk? It's a secondary storage device. Now if we talk about operating system, there are mainly 4 to 5 functionalities like process management, memory management, device management and protection and security of your file system and management. So this comes under device management. Disk is your secondary storage device, and there are various scheduling algorithms which you have for scheduling the various IO operation that comes to the processor. First is your Fcfs scheduling algorithm, and SSTS, shortest seek time first, scan, cscan, look and see look. Now let's start with your Fcfs. Fcfs is the simplest form of algorithm which says whichever request comes first will be served first. Quite very good, simple and easy to implement, but the only thing is that there will be a problem. No, actually I should say it's the convoy effect. No starvation. Why it's written no starvation? By you'll be thinking, like, suppose for example, let's take an example to understand this particular example. Now we have talked in the previous lecture session that the read write head will move in this way. It will move horizontally only in this direction. In this way only it will be always moving. Now the current position of the head, if it is in 53, the first request that it is getting, that we are getting, is 98. So it will first move to 98, then to 183, then 41, 122, 14, 124, 65, 67. This is the way how the read write head in your disk scheduling algorithm of FCFS will work. Now let's check on with the seek time. What will be the effect of seek time over here? If you see the seek time, it is the negation of your current position and the request. The current position is 53. So 53, let's deduct it from 98 and you get this value, about you get this value, 45. Then again 183 minus 98, that is the second request that it is getting, and so on and so on. You and so on, we'll move on with this whole calculation of each and every request, and we get the average seek time, the total seek time to be somewhat total 632. This you can calculate by yourself, you can check it by yourself. Now there is one basic difference in CPU scheduling and disk scheduling. In CPU scheduling, we every time needed to calculate this waiting time, response time, and here we need to calculate mainly seek time only. But there are various other parameters which we have discussed in the gone lecture session of your disk structures, which are related, like seek time, then transfer time, rotational delay, latency, and so on. Okay. Now one advantage of FCFS is very simple and easy to understand. Now no starvation. Now no starvation, we are speaking in this point of view, that is convoy effect. Convoy effect means whosoever come first, its request will be served. So if you come late, and if the request comes late and then we say no, I am not being allocated this disk, then that is not at all problem of FCFS. FCFS works in purely unbiased way. Unbiased in the way, unbiased means it doesn't give biasing to any request. What it does is that it, in whichever way the request comes, the way the request comes, the disk is the read write portion, the scheduling takes place accordingly. So requires more seek time. That's obviously because if there is a request, you can see over here, if like current head is at 53 and the first request goes to 98, even though there is a location like 65, 67, these requests are very nearby, but it won't serve because the first 98 has come, 98 location has to be accessed. Then more waiting time and response time, but obviously inefficient. Yeah, obviously if there are more number of requests, this is quite totally inefficient. Now please note over here, I written over here, no biasing is done. No biasing in the sense like there is no biasing depending on to the location or depending on to the number of bytes to be transferred. Nothing is taken into effect. Only thing is that whosoever comes first, the request is served first. That's it. Very quite simple and easy, but it's not efficient. Let's look on to with one other algorithm. By knowing the disadvantages of FCFS, we now move on to shortest seek time first. We saw that in FCFS what happens is that you know no matter if the head is very near to a request, a location which has to be location which has to be accessed, what it does is that it will go and serve the request which has come first. So that is one inefficient way. So here in shortest seek time first algorithm, it overcomes the flaws over here. It overcomes all such flaws of FCFS, and what it does is that it serves the request which is closest and closest to the current position of the read write head, whichever is near the read write. Tie is broken in the direction of the head movement. Like tie means maybe like suppose there are two location which is near to the head, maybe onto the left and right, but whosoever in which direction the head is moving, that direction first it will serve, and then the other direction. Like suppose for example, if this is the my disk, and my read write head is currently over here, and I get a location over here and also over here and over here. Now the thing is that both the places are equidistant from this head, but since if my head is moving in this direction, first this request will be served, or else if my head was being moving in the other direction, about in this direction, this particular request will be serviced. So that's one thing, and the same example is given over here. Like the same current location of the head is 53, so whichever is the shortest, so moving over here, the initially taken that the head moves over here, and then it again moves over here, then it again moves over here. So in this way, if we see, first these locations are served the request, then later 41 14, and then this 98 122 124 and so on. So these advantages is very efficient seek moves, less average response time and waiting time, increased throughput. Disadvantage, overhead to find out the closest request. Yeah, obviously, because on runtime environment in CPU, in CPU, if you see, there may be many IO requests coming parallelly all together. So it's very difficult to find out the closest request. The requests which are far from head will serve. Yeah, obviously, you can see over here that whenever the head moves in this direction, head moves in this direction, head moves in this direction, then even though there are few requests over here, it will be only serviced after the head comes back again from here to here. So that's one thing. Then requests which are far from the head will serve, that's what we talked. High variance in response time and waiting time. Yeah, obviously, every time you need to calculate the seek time. Seek time is this way, this is the way how we calculate. I put the calculation over here for your reference and to save the time. Please note that there may be requests coming at runtime, and hence the request for location near to the head will be served very fast than the request which is far from the head, and that will starve. Starve means it will not be served the request, and hence we say it is biasing. No. So if there is less load, this is not at all an this is an optimal solution, and if there is more load, then it will create an overhead SSTF algorithm. So we saw like in FCFS, first come first serve, there are flaws in that. So some of the flaws have been overcome in shortest seek time first, but again we can see that there are still many problems over here in shortest seek time first, that is high variance in response time and waiting time, and on run time, like it's creating overhead to find out the closest request. Now let's move on to the scan algorithm. This is also called as an elevator algorithm. Before going on with the scan algorithm, my dear student, let's understand a very beautiful analogy. For that I'm using this space over here. Like let's take this to understand all the algorithm, this will be a very good thing. Like this is the railway platform. Suppose this is the railway platform. I'm drawing over here. I'm drawing a lane. This is very good thing that this is a railway platform, and I am drawing a person who is a drawing a person who cleans, the sweeper, the cleans the railway station, cleans the railway platform, cleans the railway platform. I am drawing this broom. The person who cleans the railway platform about. So I have taken this example. So generally what happens, and this is generally what happens, how the person will go. The person will go, you know, the railway station is generally very long. Railway platform, sorry, the railway platform is very long. So the person will move from here and then again clean the platform and then come. Okay, so to understand elevator algorithm, this is very important. Let's understand the scan algorithm. The scan algorithm is also called as an elevator algorithm. Elevator means your lift. So you might have seen that generally when you are in a lift, you may find that if you might have pressed the key for going to the second floor about, and you have got inside the lift, and suddenly a person presses the lift from the first floor, and you have taken the lift from the ground floor. So it will stop at first floor, and it will again stop at all the floors which may be coming in between your destination. Also while coming down also this thing happens. So this algorithm says that something that comes in between can be serviced. So what happens, like suppose for example, if we take the railway platform sweeper over here, the swatch workers over here, the person may move like from here to here, and in between if he finds, like, you know, if he is at this particular location, and if he finds that there is say there is some waste thrown over here, okay, at this time, then he will first come over here. He will clean up all this waste, and then he will return to this place if there was some waste over here. If there are some waste over this location, he will clean this, he will clean over here, he will clean over and then he will move in this direction. Okay, then he will move in this direction, and then again he'll do the work as it is. So let's see again with this example scan algorithm. Head starts at one end of the disk and moves toward the other end, servicing the request in between, and reach other end, and then direction of the head is reversed and the process continues. So let's again take this swatch worker of railway station. This is a railway station. This is my swatch worker. He is having holding a broom over here. He is holding a broom. So he moves from one end to the other end over here, and whatsoever what kachra comes in between that, not this what we say, all whatever. The dirt comes in between, he will remove all this dirt. And while coming removing, you know, the Indian people, you know, when you coming, if some of the people, you know, knowing no, not having this public cleanliness sense, some of them might have put those all kachras over here. No, no, let me remove. After he cleans up all this, and while coming in this direction, some of the people might have put some kachra over here, then he will again clean up all these things. So this is what the scan algorithm does. So the head will start from one end, it will move to the other end. Whatsoever request comes in between, it will be serviced. Sometimes it's also called as elevator algorithm. I told you the examples. So you can see in this example over here, the same example I am taking. 98, 183, 41, 122, 14, 124, 65 and 67. So these are the way the request is being served. The advantage is that it is simple and easy to understand and implement. No starvation, bounded waiting time, low variance. No starvation, see over here, there it is having less biasing over here, because we know that the request always knows that I will get my request served within some time. I don't have to wait for infinite amount of time. Within some time I will be serviced with my request, and hence the thing is written no starvation and bounded waiting time. Low variance, and yeah, variance is low of this response time and all. Let's see with the disadvantage. Long waiting time for location just visited by the head. Yeah, obviously, like we can take the sleeper algorithm. Let's take that swatch worker over here. That same example. um, long waiting time. I'll draw over here. Suppose if the person might have, swatch worker might have moved from here to here. Okay, if he was over here, huh? If he is currently over here, and he is currently over here, and he has just moved from here to here after cleaning, and suddenly there was some kachra put over here, some garbage put over here. Then the thing is that after he finishes the whole work over here, then only he can return and do this work. So it will take long time to do this work, this portion work, to attend this portion work. It takes much of time over here, after the all returning from this whole line and then again returning plus. So this much of delay is that, this much delay, this much sick time, both the place, this much for servicing this particular request, that has to be taken care. So next we have an interesting algorithm, C scan, circular scan. So it will go like while both head starts at one point at one end of the disk and move to the other, servicing request in between and reach the other end, and then direction of the head is reversed. So let's start with the next algorithm, C scan, very interesting algorithm. Suppose for example, let me take that same example of that Swatch worker over here. He was over here in scan algorithm. He was doing work of cleaning the garbage over to this one end over here. He was moving here, then coming over here. So both the direction he used to work, WW work. That is here in my algorithm, he used the disk scheduling algorithm service the request at both the side while going. Both the side means in my read write head will move in this way only, that's why we are saying. But in circular scan, what we are talking about in C scan algorithm, the circular scan algorithm over here, this you can see, it will service the request only in one direction. That means the swatch worker will clean only in this direction, and while he return, no clean, no work. And after returning over here, the starting point, this is the starting of the head of the disk, 0 to 199, 199, 199. Let me write it very nicely, 1999. So the read write head will work in this direction, and when the head reaches over here, then the head reaches, let me explain it to you in sir. When this in scan, it will move in this direction servicing the request, and then the head, let me to head, then after head reaches over here, the head will again return to this position, then it will again service the request. That means while doing that sweeping operation, if we say this worker, he need not to clean while he returns. So he'll keep his jadu, no, his broom over here in his shoulder and come. It's quite very fast and very easy to come without sweeping. So if he goes sweeping in this direction, walking and sweeping, it takes time. Whereas if one direction if he sweeps and the other direction he comes walking, then he can fastly serve the request. One of the flaw in that last example which we talked was that if he cleans this direction, and then if he is currently over here in this particular place, this worker enters this one, and then there was some kachra which came after he cleaned this particular place, it will take time to serve this request, because he has to go there, then clean all over this time, then come over here. So here circulars can only clean in or one direction or service the request in one direction. So here no service. So there is one penalty over here of seek time and all, but then that is quite okay. You can, that starvation thing you can avoid for the request. So that's one good thing you have. So that's what is written over here. Same, the algorithm, the diagram and all are drawn. Please go through this so that you can understand that this diagram is very important. Each and every time we'll draw the diagram in this particular pattern only for the disk scheduling algorithm. This is the way the disk is being accessed. That's why we always draw a straight line over here. Let's see the advantages. Provides uniform waiting time. Yes, that's correct. better response time. Yeah, obviously, because while going in one direction only, the request is served, the other direction no request, so fastly he can come and take all those kachras over here, or we can say we can clean the garbage over here. No, no, sorry, it is the request, all the requests which might have populated, which might have come after servicing in this line whatsoever real time. That's very good. Disadvantage, more seek time, seek movement as compared, yeah, obviously more seek time, and one penalty is there na, because one direction it is not serving the request, so there will be obviously one disadvantage of more seek time and seek movement as compared to seek simple scan. Let's draw this simple diagram over here so that you will understand. Now look is that, always what happen, whatever things comes in between, that all things request are served in circular scan or scan algorithm, both the ways it is like that. But if there are some requests which is near to the current read write head position, it may go unnoticed. So to avoid that particular problem, satisfy request in both the direction. That is the approach of look algorithm over here. It is similar to C-scan algorithm, but instead of going till the last track, we go to the last request and then change the direction. In all the algorithm which we have discussed, what used to happen is that it goes to the last track. Let me draw over here. If this is a disk, it goes to the last track. If this is a 0th track and 199 track, it will go, and maybe there is some last request, maybe not near 199, it may be 180, so there is no need to go up till 199 and to increase the seek time, response time and all. So here there is one modification made over here. Instead of going to the last of the track, it will go to the last request. That's one modification over here. Same example is taken, the seek time is also calculated. There you may see the change in the seek time value in all the algorithm, and by which you can understand which one is good, better, or what are the changes in that, or what are the changes or approach makes a difference in the impact on seek time. Advantages, better performance compared to scan, should be used in case of less load. Disadvantage, more head overhead to find the last request. Yeah, obviously, because it depends on the last request how much it has to go to the other end about. So on runtime about, there may be multiple IO requests coming, so that again it's a problem. Should be used in case of more load. So now we have an improved version. Now let's see like how many algorithms are there in this schedule. No, it's over. So first let's conclude. If first come first serve, it had its some flaws, it has its pros and cons. Then shortest seek time first, it also had its pros and cons. Then came a one good algorithm, that is scan. Then we had C scan, circular scan. Scan was in one direction only, where scan algorithm was in one direction only. Here it in this direction, both the ways the request is being served. Look is, it will go only to the last request, and there are also some flaws in that. So to overcome that, we have this algorithm, that is C look, which is the improved version of, or which is the combination of scan, C scan and look. So scan has two varieties, C scan and look. C scan and look together is made of C look. So you may be asked, so you have much of points to write. Same example is taken, it take advantage of both C scan and look. It is satisfied request only in one direction, will go to the last request, and so both the algorithm, whichever are the positive points, are taken and included in C look. So that is what is C look about. Advantages, more uniform waiting time compared to look, more efficient, less moves compared to scan. Disadvantage, I have more overhead in calculation. Yeah, obviously, because first thing is that last request you have to find out which is the last request. So that is one thing that is there, and circularly it will work, means in both direction it has to serve the request. So that is one more overhead. Should not be used in case of more load. That's one advantage. More uniform waiting time, obviously, because it will go only to the last request, and also it will serve for both the direction and all. More efficient, less moves as compared to that of scan. So this is all about the disk scheduling algorithms and all. So I hope you might have enjoyed this lecture hearing with a very good analogy explanation. So don't forget, let's again summarize. which are the last scheduling algorithm. Again, let me draw that example. Let me draw this example of this railway platform and this Swachh worker. So Swachh worker will do in FCFS, what he will do, will be doing, which wherever kachra will come first, he'll be doing that. And then so if there is a kachra over here, he will do this. Even then there is a kachra over here, he will not do this, because he will first go over here, he do, and then come over here. So this is FCFS. So, kachra means the garbage. I am using this Hindi word very often. Shortest seek time first. He will find, no, whichever is near, whichever the garbage near, he will do all those work and then go to the. So if there are more of garbage piling over here, he will not be able to do that. First he will pile up over here. So you can understand the problem caused because of that. Okay. So then is your scan algorithm. Scan algorithm does what? It's an elevator algorithm. Elevator, you understand, na? So you can understand that elevator serving the request in between, whosoever service comes. Then C scan, C servicing the request in between, this one circular, it will work in both the direction. Look, it will look onto the nearby request and then it will serve. C look is the combination of both these things together. So that's all about the algorithm part of your schedule. Hope so you might have enjoyed understanding this particular topic. If you do like this video, please do share with your friends, and also let me know about your views if you do have any doubts. Thank you and have a nice day ahead.